Jabber? Okay, can you be? Yeah, if we have somebody that could be logged into Jabber in case we have questions. Thank you.
It's cooler in here now.
Yeah, there's.
Oh yeah, we're all here.
No. The temperature has dropped.
Yes, it is.
Substantially.
I feel sorry for you if you're
Before.
All right. All right, we'll get started with some of the formalities here. So welcome to EMU at IETF 101. I'm sure you're all familiar with NoteWell, and this is probably a little bit of an eye chart, but you might actually be able to read it in this room. If you're not familiar with it, I suggest you familiarize yourself with the rules of participation here. This is the new text. I had to change the text and re-upload the slide, so this is brand new.
Shouldn't that one be upside down?
What's that?
Shouldn't that be upside down?
I don't know. I don't know which way. The emu in this picture? All right, so we have minute takers, Jabber scribes. The blue sheets are going around. Please sign them. Just a reminder to state your name at the mic when you speak, and always keep it professional.
Not far enough along yet.
Stormy Daniels is a professional.
Yeah. Okay, so we have a full agenda, and we'll get started with that just in just a minute. I did want to quickly go through just there are particular items on the charter, and I believe we have presentations that cover all of these, which is an awesome start to the working group. So we have clarifications of ETLS and its use with TLS 1.3, and also some discussion on how, improving the handling of large certificate chains. Then there's a couple EAP AKA topics. I don't see Yari yet, so hopefully he will be here to talk about that. And then Alan was going to talk about some the EAP identity, session identity. Yeah. There are some inconsistencies or gaps in those definitions. We go back. Somehow I can go back on this thing. We also have Elliot Lear, who I do see Elliot here, and he was going to, pose some questions to the group coming from the perspective of Brewski and enrollment and that sort of thing, and how EAP or TEAP might be involved in that. So, as people trickle in here, let's get started with, let's see if I can see which slide is which. These your slides, John? Okay, now there is a microphone somewhere. Yeah, see that one? I think you have to I was told you have to get very close to that mic.
Okay, yeah.
So maybe even closer.
Yes. Yeah, here. Good. So this talk is about using EAP-TLS with TLS 1.3. Yeah, next slide. EAP-TLS is, as you know, widely supported for authentication in Wi-Fi, but the use cases has been growing over the year. It's now also the default mechanism for certificate-based authentication in the multifier standard and 3GPP 5G access networks. 5G access networks was just standardized, so this is not deployed other in test phase. I don't know how much people know about TLS 103, but it's basically a complete remodeling of the TLS handshake protocol, including a different message flow, different handshake messages, different key schedule, different cipher suits, different resumption, and it adds encryption, which leads to different privacy protection. This means that significant part of the old ETLS part specification are no longer applicable, and that means both high level from how the message flows are, but also to low level details, which contents you have in the different messages. But I think people definitely want to use TLS 103. It provides significantly improved security, privacy, and reduced latency. So TLS draft Matson, TLS updates the old draft, was discussions on the list. Thanks to Alan and Bernard, for the many comments, and also Jim. I think the draft now is in a pretty good shape. And it only lists additional or different requirements compared to RFC 5216 or TLS 103. Next slide. So here is a high-level overview. What is changed? So here is an ETLS hand message flow when you're using ETLS 1.0, 1.1, or 1.2. They all look the same. And if you look at ETLS when you use TLS 1.3, it looks quite different. And what has changed is that you have, for example, here in the client, what the client sends, you have different messages. The server basically only sends, instead of 2 blocks of messages, only sends 1 with different context. And basically, you also get rid of a whole single round trip, which is no longer needed when you do TLS 103.
Okay.
Yep, next slide. So a little more into what details, what difference. Resumption works different in TLS 103. It replaces the earlier session resumption mechanism, there were several, with a new PSK exchanged. As discussed on the list, the P-shared key exchange shall not be used except for resumption. And the resumption also works a little bit different. When you use TLS 103 with resumption, you need to indicate, the server needs to indicate support of resumption in the initial authentication. And to do this, it sends a new session ticket message, which contains a PSK identifier, and some other parameter. And if the client has received such a new session ticket, it can use that PSK identity and the PSK to negotiate resumption. And then it's up for this. Typically, if you have a ticket and it's valid, you should do resumption. And typically, if the ticket is valid, the server should accept resumption. And I think next slide, we can see example on how this looks. So basically here is the ordinary handshake, and then after the client authentication, the server sends a TLS new session ticket to the client. So you get 1 additional round trip there. And then when you do a resumption, it's a simple TLS 1.3 handshake, but with PSK. So there's no certificate authentication in the resumption. Questions? Yeah. Next. Privacy is another thing that handles can be handled very differently. TLS-103 increases and simplifies the privacy by encrypting a large part of the TLS handshake. In earlier versions of TLS, large part of the handshake were not encrypted. For example, this certificate was sending clear text, which meant that to use EAP-TLS with privacy, the client sent an empty certificate list, and then you redid the handshake basically twice. In TLS, there is no need to do that. Everything here in yellow are always encrypted, including both the servers and the client's certificate. So you basically get the privacy features for free. And of course, in EAP, you also send an identity here early before you start TLS. So then you need to use an anonymous identifier. And the current draft says that you must use an anonymous identifier when you know that the server supports TLS-103.
Yeah, that's going to be a follow-up.
Can you use the mic, please? Sorry.
Bernardo Boba from Microsoft. The problem, though, is if you don't know, right, and you start that, then you're going to fail. So it's kind of weird, like, and the problem is, so you're starting off, you don't really know whether the other guy does. You can't really include it. Then you've kind of leaked your identity, and even if you come back, right, people can. So anyway, yeah, I'm not sure how you solve that, but that's kind of it. There's a gotcha in there.
Yeah, I agree. This is basically the only area. I think there is more clarification needed. But I think this is already a problem with early version of TLS. There's no way to know that the server in EAP-TLS ever supports privacy. Right. Yeah. Yeah. Next slide.
Okay.
Yeah. Yeah.
Not that this is Elliot Lear, sorry. Not that this is an objection at this point, but just a note of, an observation, which is if people are doing radius proxy functionality and they need the information that are in the certificates, they're going to lose that in 1.3. So some people, I think, will view that as a feature, and some people may view that as a problem, depending on one's perspective. And I just want to note that that's an issue there.
Sorry, just to clarify that, I'm not aware how you can do half the EAP conversation and then proxy it. So the issue, speaking from this is Alan DeCock from Radius. The issue is that once you start the EAP conversation, you either do all of it or you proxy all of it.
No, it's radius versus EAP.
So what I'm saying is in the radius layer, you proxy based on the identity, and that happens no matter what happens inside EAP. And sort of looking at the certificate and then deciding whether or not to proxy it is something that's rather a lot more complicated and typically not done.
Yarriarko, I'm also trying to understand what the case actually here is, and maybe you guys were just speaking past each other. Are you, Elliot, suggesting that there's like an EAP goes end to end, and then there's one of the proxies in path is looking at the EAP traffic, even inside EAP TLS, and looking at the certs? Is that the case that you're thinking of?
We have a use case. I'm aware of one use case that we're considering. Sorry. I'm aware of one use case where we're considering doing exactly that, where we're going to split essentially different functionality out. And we don't have to respond directly, but if we have the certificate information, we have enough information with which to make decisions that would then that might otherwise be made directly by the Radius server. And so there are a couple of. It's a fairly involved use case, but having that information hidden is going to close off some of those use cases. We can, again, as I said, it could be considered a benefit or negative, and I can flesh that out a little bit more over time. But this is something that we have to, I think, understand a little bit more in the EAP use case.
Is this work going on in another working group, or is it proprietary?
It's proprietary at the moment, but it may not be for long.
So another thing that changes is the key hierarchy. TLS.
Can I? Yeah, Doc, so sorry, I was slow, but I wanted to follow up still some more on this topic. So that's the use cases that you or anybody else in this room know of are not current. They are upcoming or future ones.
I can't speak. The ones I know of are not current. There may be others that, I mean, radius proxy is not a new thing.
So just to try and close that out, I think watching the traffic and then proxying or not based on peaking inside of EAP but not actually terminating it, that's I would say that's a hard no. If you want to terminate EAP and then after you've decided to authenticate the user, somehow ask someone else whether or not they really should be authenticated, that's more possible. But I would say that's largely outside the scope of EAP. And it can be possible. And people do this today. Yes, your certificate's okay. Let me look you up in LDAP. Oh no, you're no longer allowed. That's done today. And I think whether or not that's LDAP or SQL or further proxying is all fine and is compatible with this.
So the key hierarchy changed. TLS 1.3 replaces the pseudorandom function used in early versions. They're slightly different in 1.1 and 1.2. 1.3 completely replaces it with HKDF. And it also completely changes how keys are derived. Here I think a specification is needed to avoid non-interoperable implementations. And the suggestion in this draft is to use the TLS exporter, which is what the function TLS 1.3 has made exactly for this use case. And this is what Quick is using. And it's very simple. And then all the other, these are basically the three things you need. Then all the other EAP-specific things can be derived exactly as in EAP TLS RFC 5216. Fragmentation. So this, there was a lot of quite a lot of discussion on the list regarding fragmentation and the problem that some nodes cut off the communication after 30-40 packages. So I added quite a lengthy section to the draft to explain things that can be done to avoid or at least limit fragmentation, reduce the number of packages. And this has become easier with TLS 1.3 than earlier versions. Alan?
My 2 cents is that could probably be split out into a separate document because we probably do want recommendations for earlier versions of TLS. And as my message on the mailing list said, right, I mean, you can bloat certificates out with names, addresses, groups, OIDs, and that's completely independent of any of this. Yes. But there should be recommendations separate from 1.2 and earlier from 1.3.
Mohit, so my initial feeling was 1.3 recommendations stay here, and anything before 1.3, so for what's already deployed, should be a separate document.
Of these, I think, so let's go through them. I think one thing is to use mechanisms to get the certs or certificates changed as small as possible. You can use ECC. You can, of course, you can use less number of CAs and sub-CAs, but that probably you have a architecture that you want to use. You can, one number that takes quite a lot in some certificate, it's subjective alternative names. If you have 50 or 100 of these, they take a large amount of space. And these are all general, would apply for any version of TLS. Then you can use mechanisms to reduce the sizes of the certificate messages. One thing that you can do in TLS is to omit certificates that you know that the other endpoint knows about or has access to. In TLS 1.2 and earlier, you can only omit the top self-signed root CA. In TLS 1.3, you can omit any trust anchor. Basically everything except the server's own certificate. So that's TLS 1.3 specific. Then you should use the cached information extension. That's for all version of TLS. And then you can use extensions to reducing the size of certificates with compression. This is not an RFC yet. There is work in progress in the TLS working group. And this is TLS 1.3 specific. But I think the idea to move this out into a separate is very good. Yeah. Some other smaller changes. OCSP handling in 1.3 is a little bit different. The OCSP information is sent inside the certificate's status messages instead. This means that you can send OCSP information for all certificates in the chain. TLS strengthens confidentiality, key strengths, and cryptographic negotiation. So I made some slight updates to the security claims section. That applies when you use TLS 1.3. And then the cipher suits are different. So the must and should in the earlier versions do not apply. Basically, these cipher suits are not available. So for this draft, the current draft states that when you use TLS 1.3, you follow the recommendations and must in TLS 1.3 without changing anything. And for earlier version, of course, it's RFC 5216 that applies. Next. So I think after discussion on the list, I think this draft is in a pretty good shape. Would like even more feedback. And then, of course, implementations. We have at Ericsson has not implemented it yet. We are discussing to start implementation of it. It would be great if there was several implementation. We could test them against each other. And then I think this should be adopted as a working group item.
Okay, how many folks in this room have read the draft? Okay, quite a few. Does anybody have reasons why we shouldn't adopt this draft? Okay, so we'll take it to the list, but I think we'll do that. And certainly we have a fair amount of excuse me, people reading the draft, but getting more reviewers would always be good. And we can also discuss, I think, splitting it out. I think, does anybody feel we have to resolve the splitting out issue beforehand? I think that's something we can do in the working group, splitting out the certificate handling or the fragmentation. Okay. Thank you.
Thanks.
I think next on the agenda we had Yari.
Okay, so I'm going to talk about two drafts. One is sort of a bug fix and accommodate some new situations that existing methods need to deal with. Another one is a real new piece of functionality, a small piece of functionality to enhance something. Next slide. And I mean, just as a background, many of you are probably aware of this. I'll just briefly cover that. But we obviously had lots of work on EAP back in the early 2000s or so. And since then, not much has happened in terms of specifications, but there's been lots of deployment and some amount of usage. I think the implementations of some of these technologies are in the billions in terms of existing smartphone clients and such. usage, maybe not is at that quite at that level, but fairly large nevertheless. And the thing that in the past, how these things were used for the EAP SIM and EAP AKA type authentication, the idea was that you could use operator authentication infrastructure, but you would still come in through, like when you would connect through wireless LAN, then you would use EAP and authenticate with EAP SIM or EAP AKA. And then if you came through 4G, for instance, you would authenticate with the native mechanisms in the 4G UE interface protocol, and that's not EAP. But in 5G, this is going to change. So they plan to allow both EAP and this older, direct plain type of SIM card authentication on the UE interface. So when you're coming into 5G network, you could authenticate directly with EAP, and obviously to support EAP AK prime, which is the default mechanism there, but also potentially other things like EAP TLS and so forth. So that's kind of the motivation of like, why are we talking about this topic today at all? So that's why it's important that we make sure that technology actually works in today's situation. We fix bugs and so on. Next slide. So this first draft, the RFC 5448 bis, is an update to EAP AKA prime. And if you recall, so EAP AKA was the 3G authentication protocol, and it was enhanced with this in this prime version in 5448, 2008, I think it came out. And basically, the idea there was that this provides better binding to some of the parameters of the context that the authentication is happening in. And the draft that I have written with my colleagues, it's a small update of this EAP AKA prime. They are bugs in the current specification, things that we missed at the IETF at the time, or specifying some behavior for situations that were not covered by the old specs. And there's a 0.0 version that I was briefly mentioned or presented in the previous IETF. There's a 0.1 version where we, as we worked through, this in various places at the 3GPP and IETF, and also we realized that there's a couple of other issues also than the one that was in 0.0, which was also only about the binding, but there's other stuff too. And the idea here is don't add any functionality, just make sure that it actually works, as the method has been defined, and that requires a couple of tweaks or bug fixes. But we could obviously update like security considerations when we learn. We've certainly learned of some attacks in the space of pervasive surveillance, for instance, that we could probably document here. But security considerations is fair game. Adding new features, I thought would be bad for this particular draft. Next slide. So the three updates that are currently there, and since we have discovered a few, it might be possible that that the list of three grows a little bit to 4 or 5 or something. And I want to work with you guys to make sure that we got everything. So the first issue is this binding issue. So EAP AKA binds the authentication to the produced keys, so that you have some context information, like we're doing this authentication for purpose blah, and then this purpose blah is defined through a reference that the old RFC points to a 3GPP spec that has a table that if you are doing wireless LAN authentication, then do this, and if you're doing something else, then do that, and so forth. And now they're adding essentially a new entry into the table, like 5G, then do this. And on its own, this is like we're pointing to a particular version. The RFC points to a particular version of the 3GPP spec, and now a future version of that same 3GPP spec is going to say something different. So you could, perhaps if this was the only thing, we could perhaps let it slide and not update. But I think it's actually a good practice to, like, if we have an actual interoperability issue, this would result in an interoperability issue that people can't talk to each other if they don't get the keys right. So it's good to update specs when something like that happens, even if it's in a reference, because it's so important piece here. The other thing is kind of like a 5G, 3GPP development that they used to have particular types of identifiers, and now in the new architecture they have added some new types. So they have these temporary identifiers, and then they have more permanent identifiers, and they play a different role than identifiers previously did in older systems or generations. And it's important because the identifier also goes into the key calculation. So if the identifier, one side thinks that the identifier is A and the other side thinks it's B, then that would be bad again. So we want to be absolutely clear that you shall use this ID as the ID. And there's a couple of different answers. It could be the actual ID that you sent on the EAP communications, or it could be the corresponding permanent identity. And there's arguments either way, but I went to the 3GPP meeting once or twice and realized that, they are actually discussing this, like what would make sense here. And so I feel that the RFC actually needs to be updated to say what's going on.
Then, Kata, just you could consider using all of the IDs you know about if they're going to be known to all parties. You don't necessarily have to limit to just one.
That is true, but I still want like exact same bit string on both sides, right? Yeah, so that's a clarifying thing. I should also have mentioned that there's like ongoing work in 3GPP about like their new authentication architecture, and there's some appendix that has some text about EAP aka prime and how it should behave in 5G. And then the appendix also says, when the RFC is ready, move this text to the RFC or let the RFC specify this. But this is relatively urgent because they are actually doing this right now. So I would like to get moving with this particular draft. And the final thing is this session identifiers, which we've discussed on the list, that actually applies to multiple methods, EAP sim and AK and AK prime. So this particular draft actually fixes that for EAP AK prime as well.
Yeah, John Mattsson, Ericsson. Now you update the 2008 reference to release 15 reference. Seems like we will get into the same thing when 6G is defined. If it is there any way to do this in a more generic way so that it's future proof?
That's an excellent question, and we should figure that out. I mean, I think there are ways. I mean, we can refer to the spec or its future versions or whatever, suitable language. But the question is, what do we want? Like then a future change of this nature, that the table changes and keys will be different, and nothing in the RFC indicates that. So if that's what we want, we can make that happen. But it might not be. I'm not saying what the right answer here is, but I'm just saying that there's several answers and we should decide.
Yeah, I had a similar thought, and him asking the question made me get up here. I'm Margaret Cullen from Painless Security. One thing I'd think about is, whether it makes sense for there to be an IANA registry that when 3G updates things, they put new values in, something like that we could refer to, since that seems like or if they have such a registry, we could refer to that. I don't know whether they have something like that, but that seems to be the way we normally solve that sort of problem, rather than updating the RFC over and over.
Yeah, I think that's also probably reasonable. It still doesn't get us away from like somebody has to update code. Like normally when something like a new situation comes along, somebody can send an attribute and we can just ignore it. But this is very different because it actually goes into key calculation, so we can't really ignore it. We have to understand it. And now somebody needs to signal us that, this is a new thing, new situation. Looking back, maybe I would have designed the protocol slightly differently, that it would actually be explicitly signaled somehow, but that's not how it was done.
Mohit, I just think these updates are not going to be that frequent. Like, we don't expect 6G anytime soon, so we can live with updating the RFC.
For yourself, I expect it very soon. But yeah.
This is Alan again. Just one question about point 3. From a strictly timeliness perspective, it may also be interesting to just duplicate all those session identifiers in the session identifier document, because that's really 5 paragraphs of text, and implementations are depending on it now. I mean, it doesn't hurt to update the session identifiers for AKA prime in 2 places. If one goes out in 3 months and the other goes out in a year and a half, it might be easier for implementers.
Yeah, we can consider that. Thank you. Next slide. So next steps, where are we? As I said, I think this is fairly urgent. Like I would like to get this done in a couple of months. It's not a lot of specification work, just a few loose ends to take care of. I would like to get this as a working group item as soon as possible. Would like to get you guys to tell us what other things we missed. And also I'd like to work with the 3GPP people to figure out if they think we've missed some. And by the way, there is some discussion going on. Like there's several people, overlapping participation on that. So that the coordination piece is probably under control, but would be very helpful if others also participated.
Margaret Cullinan, it's been, 15 years since I read AKA. So I don't remember what the security considerations say, but I think whatever we end up in this document should be accurate based on the current way we assess these sort of things. So I think you should update the security consideration section.
Absolutely, and I'm going to take a wild guess that we are better now at writing security consideration sections, or at least I hope so.
So how many folks have read this document? One. Not quite as many. So I'm not going to ask if there are any objections since people haven't really read it, but we'll bring that up on the list as soon as we can, because it seems like it should be pretty straightforward. Okay. Well, I guess I will ask, is there anybody who thinks there's something would object to taking this document in this room, just so we can get it out if there's there? Okay. So we'll take that to the list.
Okay. The other draft was actual new functionality, and it's optional functionality. So perfect forward secrecy. And the background for this is, I mentioned it in the previous IETF. The issue is that there's been reported cases of intelligence agencies stealing large amount of, potentially like all the keys from a SIM card manufacturer. And then if they have those keys and there's no perfect forward secrecy, then essentially at any time they can look at the traffic later. And since this was discovered, there's been obviously lots of concern about it, and people have done stuff. They've taken care of security between the manufacturer and the operator better. They've improved their processes in manufacturing plants. They've, tightened up everything possible. But still, the opportunity for this remains. I mean, at the end of the day, you can, hand somebody a national security letter or something, and they'll have to comply. So if we had some technical means of dealing with this problem, it would be good. Next slide. And so what we've done here is essentially a so draft ARCO EAP AK PFS is a backwards compatible extension on top of EAP AK prime that adds a Diffie-Hellman exchange, and then the output keys from EAP will now provide perfect forward secrecy. And if there is a compromise of the previously described nature, then that's still a bad thing. But if intelligence agency wants to use those keys and look at the traffic, they actually have to be active attackers and not just passive attackers. So that's forcing them to do more, and that's a good thing. Generally considered a reasonable thing. There's tons of details. I don't go through that. Hopefully people can read the draft and look at the details. It can probably be done in multiple different ways. There's been some discussion in 3GPP about this. Also about this, doing it in EAP, but also some other approaches. We think this is a reasonable approach, given that, if you cover TLS and PFS and cover EAP-AK and PFS, you pretty much covered, a very large fraction of all practical use cases for some of those networks. And then there's some other alternative designs where you do things in the local network, but the downside with those approaches is that then whatever high quality keys you get out of that, they are left in the local network, whereas in some of the systems you might actually want to have the terminal and the home network also discuss with each other and using these high quality PFS protected keys. And so it's possible with this kind of design, sort of backwards compatible fashion. Should mention that there's an IPR notice on this draft. Probably should also mention that there was some IPR by somebody on RFC 5448 also. And also should mention that this perfect forward secrecy thing is discussed in 3GPP, but they have this two phases. This phase 1, which is like ongoing right now, and it's going to finish in 5 months or 6 months or something like that. And then there's phase 2, and the perfect forward secrecy thing is in phase 2. That's not something that they can do in this timescale. So if we complete this in reasonable fashion in IETF, or have some solution in IETF for this, then they could take use of that in their next release, not the one that they're currently feverishly working on. Next slide. So I'm going to argue here that it's important that we actually enhance our protocols to respond to these massive attacks by various organizations, and there seems to be demand for this in the mobile industry, so that's good. An opportunity to do things right. So I would also like to argue this thing to come to the working group, maybe with a little bit less urgency than the previous one. That one I really need done soon. And the coordination thing, again, is important and ongoing. That's it.
Hey, Aaron Kababel for Radius, same as Alan. So there's a long-standing issue in EPK and EPSIM and the rest, and that the permanent IDs are revealed the first time the supplicant authenticates. If there's appetite for sort of doing perfect forward sequencing and really sort of stopping state actors finding out information about UEs, is there any appetite in fixing that?
I'm sorry, I didn't completely hear or understand so what are revealed in the authentication?
The IMSI number of the SIM card is revealed.
Okay, yeah. There is, and that's the thing that I was on the previous presentation talking about, that they have this temporary ID and then the more permanent ID, and now they're fixing that. They have fixed it. So that's good.
John Mattsson, so already in phase 1, it's now mandatory to support curve 25519 for encryption of your identity.
Yeah, and I mean, obviously there's tons of details about that fix, because the core of the core will still know who you are, but maybe people elsewhere will not learn it as easily as they did before.
And so how many folks have read this draft? Okay, 1 or 2. Okay. And so with the coordination with 3GPP, it seems like they're still kind of, settling towards an approach. Is how, like, do they have a timeline for this phase 2 and when they would decide that? And
I think the phase 2 is going to finish a year from now.
Okay.
Am I getting that right? But I mean, as a general approach, I don't think we at the IETF should necessarily. I mean, we should respect people's timelines, but we should do our own homework. That we have a protocol, right. We're going to fix it for these and these reasons, and then it's available for people to use if they so desire.
But if they need something and we don't have something ready by that time, then that could be a problem too. Yeah. Okay, so I think, does anybody have any other comments on this draft? I mean, I think we need some more discussion on the list, and you didn't ask for adoption here, or do you want to wait a bit on that to bake it more? Or
I thought I did ask for adoption. I'm just
Okay.
expressing a urgency difference between the previous and this.
Okay. So then we can queue them up then. Okay. All right, we're cranking through the agenda here, and I think Alan is next with session identifiers.
Hopefully this should be pretty quick. Next
You
slide.
might need to get closer to the mic.
So there's the session ID, just for recap, defines that. If we go to the next slide, it says they must define these things, and people like to ignore musts. So if we go to the next one, each session ID has not been defined for fast re-authentication for SIM and AKA, and no session ID derivation was defined for AKA prime or PEEP. The charter could probably be updated to add PEEP if we care. I've gone through a bunch of the other EEP RFCs. They all look okay, but it wouldn't hurt to double check that. Go to the next slide. The TLS-based EEP methods don't have this problem. They cache the TLS information. You can always derive the session IDs for re-authentication. Non-TLS EEP methods require different things. So this is, I suspect, why it was missed. I wouldn't be surprised if a lot of the vendor-specific EEP methods have similar problems, but it's their issue to fix. Specifically, this is needed for ERP and fills for IEEE 802.11ai. Next slide. So this is the proposal based on Uni's comments to the mailing list. EEP AKA prime, SIM, and PEEP. And that's really the bulk of the content of the document with some paragraphs around it. Bernard.
Yeah, Bernard Bubba. One way that you might consider fixing this in the future was if there was an IANA registry, then basically IANA would have checked all these documents for the allocations and made sure they didn't miss them. So that might be something to consider, as having this document establish a registry, populate it with all that stuff, and then the good folks at IANA will check, going forward. So you don't have to do this again, like in another 5 years. Oh, these documents.
Yes.
Yeah, I think some of these were published before we did the session ID, I think, maybe, or I think AK and SIM. But yeah, and some were after. But
next slide. So specifically, this will update 5247, 4186, 4187, 5448, 5247. And I suspect, based on my earlier comment for AKA prime, it doesn't hurt to put the text in this document. And if they get published at the same time, we can just delete it from this document. And if AKA prime starts being contentious, then I don't know. Next slide. Any questions? Hopefully, barring IANA registry updates, this thing really should be a couple of pages. I didn't have time to get it done before IETF, but I'll get it done next week. And if there's no IANA registry updates, it could be published effective immediately, so long as people review it and like it. If there are IANA update registries or registry updates, that will take a little longer, I suspect.
okay. So we'll be waiting on a draft. I don't know if anybody want to discuss the issue of whether the AKA prime thing should go in this draft or not, or do we just wait and see how things progress? Okay, we'll just wait and see. All right. I think this means did I not? Oh, here we go. All right. Elliot has some questions for us. And he's going to probably tell us a little bit about this Brewski thing.
Hi, I'm not as tall as Alan. Okay, so I'm Elliot Lear. I've been working on onboarding of little things and sometimes big things with a bunch of people who are in the room. So we've been most of our stuff we've been focusing on in either ops area working group or in the Anima working group, and it's all about a lot of it's about trusted introduction and figuring out what this thing is and how we're supposed to protect it from a network perspective. Next slide, please. So I'm sort of new to EAP. Okay, that is to say, I'll admit it, I know very little. So I figured I'd come to the experts as we begin to sort out some of our problems. And there's not even a draft yet for, in terms of a specification, but we're beginning to sort ourselves in terms of trying to figure out not only the problem space, but closer to the solution space. Next slide. So that's my way of saying be gentle. We have this fundamental problem. We've actually done a fair amount of work for Wired and can onboard devices. There's a person who's not in the room, actually, Michael Richardson, who's been leading a lot of work in the Anima working group to basically do a trusted introduction between a device and a local deployment, where the device, or what you might call the EAP peer, has a very limited ability to retain things like a certificate store, a trust root store. Maybe they have one or two or three space for one or two or three certs at most. They certainly don't have anything like what you'd find in a browser. Okay, they just don't have the space for that. And to give you an idea, I've had arguments with people over, using 5 to 80 bytes, on processor capabilities that range all the way down to an 8086 or a Z80. So you threw out that Z80 book already, right? Guess what? It's all back. So we sort of sorted this, as I mentioned, for wireless, but for wired. But for wireless, we have a couple of problems, only some of which are this organization's issue. And it really goes like this. We've defined this wonderful flow that says, let's do this little dance with a nice little RESTful interface between the device and the local deployment, which we call a registrar here, and the local deployment and the manufacturer, which is a somewhat optional step, to say, let's let that manufacturer do a trusted introduction for the device and the local deployment. This is really nice. And of course, to do that little dance, you sort of have to have some connectivity to the device. But if you're on a wireless network with an 802.11 network, you have a very limited connectivity and probably no IP connectivity until you have credentials. So it's a little bit of a chicken and egg problem. And so we're trying to sort out, to break out from the chicken and egg problem. And there are a couple different ways to do this that we're sort of exploring. And there's a draft, and I'll point you at it later to just mention, what the problem space looks like. And so 802.11u, for instance, has an ANQP extension, which essentially says, here's some TLBs. You guys can talk in some structured way before you actually do a communication. And actually, there's something similar, in terms of doing network identifications, the 802.11aq. We're not entirely thrilled with that either, as it turns out. We're pondering using TEEP to do this, which is why I'm here. And just to get, at least to to identify the right network, we're thinking of doing something with device provisioning protocol, which is work being done on the Wi-Fi Alliance. Again, that's not something we have to worry about here. And we are pondering the use case where you have an EAP TLS based mechanism, and maybe you have other EAP methods as well. And we're not really far along with the other EAP methods, but we started with an EAP TLS use case. Next slide, please. So here's my understanding of TEEP. You have sort of an outer TLS communication. This is work that that was probably done in this working group. You have an outer TLS, which you can defer the authentication of the endpoints until just before you're ready to send back an EAP success. You have something of an inner, and you can use all these lovely methods inside that nice wrapping, which we like. You have an EST-like enrollment mechanism, and you have an ability to get back trusted server routes, this is all good stuff. One thing you just lack is this trusted introduction, so we want to do an extension for the trusted introduction. Next slide, please. So now Anima is that trusted introduction. I think I probably have covered everything in this in this slide already. So the basic idea is you want to end up in an end state, at an end state where the client has at least one trusted element in the local deployment that it can retrieve more information from, where it had no contact with the initial deployment already. And don't think laptop, think light bulb when you're pondering this problem. Okay, there's no user interface on the device at all. Next slide, please. So in exploring TEEP, right, some of the things that we've been looking at is actually TEEP says you can roll in EAT methods underneath. There's a nice little TLV defined for that. This is nice because it's very clear how you do an intermediate result. In fact, there's an example given in RFC 7170 of exactly how to do that. Well, goody, I could just do that. On the other hand, if you create a new EAT method, that means it's, somebody might get this misguided idea that you should do the new EAT method without the outer layer protection that TEEP provides, and then they have a choice. They can either do an additional outer layer for themselves, or worse, they don't do anything, and you end up with some weird exposure in a vendor method. That poses some small problems. On the other hand, we can create new TEEP TLVs, and this guarantees that the thing's only used with TEEP, right? So you get the outer layer protection. But there's a little bit of confusion that we have. Maybe it's not in the draft, maybe it's just in Elliot's head and other people's heads, as to how to do the intermediate result with a method. Next slide, please. So to give you an idea of sort of the sample flow, and this is just a sample and it's incomplete, that we're thinking about, right? And yeah, this is an eye chart. You go through, you do your nice little hellos, and so at some point, right, you come to determine that maybe you actually need to get a deployment cert, and if you don't, you can skip this part, and and go right to, say, EAP success, right? If you like that, if you know the if you have a local deployment root cert, and but the server says, oh, you might need to re-enroll, maybe you skip the Brewski stuff. But otherwise, we define essentially a new method that we're currently thinking about in terms of TEEP to essentially do a voucher request, this is an Anima construct that there are several different drafts to do this, and then a voucher response, right? At which point you then go on to do a local registration using the nice little mechanisms that are already in a TEEP. So all we want to do is, at this point, is a pretty small extension, or what we think is a pretty small extension. Who knows if we're right about that. Next slide, please. Okay, so I mentioned there was a draft. There's a draft. And so we've defined a bit of a problem statement. We look at a bunch of different methods. And so we're seeking, it says seeing, we're seeking discussion about what's the best way forward. Now, to put this in a little bit of context, we have really good technical people in this room, and we want to start here, but the overall solution probably has to deal with a pretty broad base of characters, like the people who make the light bulbs, or the people who do these little devices here that look like the smoke detectors or things like that, or the monitors. So it's a pretty broad problem that we have to think about from an industry perspective. And so we want to take it, reasonably deliberate and try and figure out the right thing. One question we have is whether TEEP is actually a useful tool here. It looks nice, okay? The mechanisms that are provided look really good. The problem is there's not a lot of adoption, as Alan pointed out in the Ops Area Working Group, and that does concern us. And just so you know, Alan, I did these slides before you said that, okay? And so we're concerned about that.
This is Alan. My 2 cents is EAP is probably the right mechanism. As Yuri was saying, 5G is moving to EAP and said, don't invent your own thing. some TLS-based method is probably the right thing. Inventing your own crypto is evil and wrong.
Right.
I would probably argue that it's better to do it with TEEP and just sort of push people to use that than to try to patch one of the other EAT methods. TEEP isn't that complicated, and suck it up, people, get it done.
Yeah, I mean, it sort of looks, it smells right, Bernard.
Yeah, Bernard, I think the thing to think about is kind of all the dependencies for all the use cases, and the environments you think of this using it. Will they have EAP or are they not, or is it like a consumer light bulb you're selling to somebody, a grandmother or something? So that's probably the more pertinent question, to just figure out what you're likely to have in your kind of environment.
Yeah, it doesn't actually say it on my badge, but I work at Cisco, and our focus is primarily on an enterprise use case.
Oh, so they will be in that. They'll
So
have all
it's
that
definitely
info. Okay.
in the EAT territory. But as I mentioned in the beginning, right, we also want to have answers for the other use cases, but maybe that's not EAP-ish, right? That if you look at a light bulb and the way things happen, or like the Ring doorbell is a perfect example, right? They create their own APs and such, and then you can just onboard in a consumer way like that. But one of the area directors was frustrated in his own house. He's having difficulty with all this stuff because he's got a lot of equipment.
Yeah, this is Alan again. Not having manufactured light bulbs or anything, but doing security, my 2 cents would be suck it up, right? This is how we know to do it right.
Mm-hmm.
Anything else is very likely to be wrong. And if they don't have enough CPU, you probably shouldn't be on the net, right? If you can't do this kind of stuff securely, unless someone's going to come up with a 0 CPU TLS, encryption, whatever TLS method, then we don't know how to do it right other than this.
So just to give you a little flavor for the constraints, when I talk to partners about this, what they say, what they're aiming for is they want to minimize the amount of code that they can't reuse. So they're looking at DTLS, for instance, and so there's a TLS stack they're probably aiming at. So we can probably do something in that space. The heavier it is, the heavier the anima part is, the heavier the EAT part is. That stuff, since that code is only used on onboarding and probably these guys are probably all on all the time, at least at that level, right?
Yeah.
You do like an authentication a month or something like that, or an authentication every couple of months whenever the power goes out in a room or something like that. Then they get a little bit antsy because that's code that they only had to use this much, and it took up this much space. And that's something we can't solve for them. And we're not going to try to solve it here, to be clear.
Okay, he really is tall. Oh my gosh. Nancy Kim Winget. So just to add on, so fully agree, which is why Elliot is mentioning TEEP. So I'm also from Cisco, been working with Elliot on this. So I was just going to add the motivation for why EAP is, as we're onboarding this, it's not just the enterprise, but trying to leverage the fact that we're onboarding on a wireless medium, that being Wi-Fi. So it became natural that if we're going to do Wi-Fi, there's already the definition of using .1x and therefore EAP. The addition that we have in here, I just wanted to add to what Elliot is mentioning, is when you look at Brewski, the thing that Brewski is adding is that voucher request response, ergo EAP has a request response. So a natural place, and that's the question mark for the group, is we could add into TEEP the specification for doing that voucher request. And we bantered it on, is it a separate EAP method? Likely not if we can do it with an EAP. The other question is, when being an author of TEEP, right, the messages that we put in there for the certificate enrollment is just for that, whereas EST is broader. Ergo, the question of when we do the full, and encourage you to look at the Brewski, is whether we need to extend the TEEP to do what EST really does, or just reference EST, which then gets to the question of channel binding.
Thank you, Nancy. That was well put. Margaret.
Margaret Cullen again. I actually have a couple questions. I didn't author TEEP or run the EAP working group or implement free radius. So, I had trouble understanding the picture. I don't know if you go back to the picture, because I'm wondering, you get this thing and you go, we might say yes from here, or we might go to the master server. Now, is that an inner method that's going to do some sort of communication with the master server?
All right, let's see here. This is wireless, right? Ooh. Okay. Time to deep dive. And by the way, the person behind you can really deep dive, just so that you know. He's the brewski guy.
I did look at it on my phone before this meeting, and I didn't understand it then either. So I'm.
All right. So I'm not going to. Again, I'm not the expert on TEEP either, which is why I came to you guys. So I'm going to give you my best interpretation. Everybody, can get up and say, "Ooh, that's wrong," but and I'll happily take that. Right. So we start out. We do the normal EAP dance with EAP TLS. This is, or I should say, TEEP dance here, right? This is where we're starting in this discussion.
Mm-hmm.
So you have a client hello, a server hello, and so there's a decision point actually up here. It shouldn't be down here. It should be up here. If the client and I think these might actually be reversed if I'm looking at this correctly. If the client and the server know each other, then in your code path, the server has the ability, I think, at that point to just send back EAP success if life is good, right? And then you can just bypass all this other stuff. If the server has some reason to not send an EAP success, there could be two reasons for that. One is that it doesn't recognize anything from the client. Then it could then say, okay, continue down the flow. And it could also, it could do, and it does this with essentially the EAP request frames. And so that's our understanding of the logic behind that. And so that's where you get branching in this context. Does that explain things a little bit?
A little bit. I sort of
This is
did
early
this is
days.
the case the first time you come on, and there's no caching and there's no anything.
Right. Then
What
you
I'm
just go
not
through the
getting is the part where the request goes to the master server, right? So you've got a AAA server, and the AAA server is talking to you, right? But at this point, is the AAA server going to do some, like, on the inner tunnel, going to do a request to the master server that the AAA server gets an answer to and then answers you based on it? Or is the request forwarded in some way where the master server now talks to the client?
Yeah, I don't have the full picture here. That's sort of intentional.
Yeah,
because otherwise it gets really messy. But
because your channel binding question becomes very complicated if you're going to change who you're talking to. And
so you're always talking to the authentication server. Okay, the authentication server is going to forward a request on your behalf to this thing called a master server, and then it's going to respond, and that request itself is signed by the master server in such a way that the peer will recognize the signature for authorization and authentication for this purpose.
so you have sort of almost a degenerate tunnel there where the signatures are effectively creating a bit of a tunnel to the master server.
Yes. And
okay.
the person who designed all that is right behind you.
Okay. No, I tried to understand this and I couldn't. And so now I think I'm starting to get what you're talking about.
I apologize for the abbreviated flow here.
I would recommend figure 1 from the Brewski draft, which should align in your head pretty quickly. If not, I'm happy to talk about it further.
I didn't see these slides
Yep.
soon enough to read them.
I'm sorry, this is Max Pritikin. We might have moved on a little bit, but I wanted to address the question around bringing Brewski into this space as opposed to other use cases. And the Anima use case is around the broader context of autonomic networking. So it's kind of network devices and how they would be set up and work together. The ACE working group is taking that and moving it into constrained space. So they're doing some of the definitions to move a voucher, the blob that we're talking about that's signed, that has to be gotten from the master server. They're doing work to convert that into a format that's better for constrained environments, which would also work a little bit better because it's COSA based, et cetera, would be a little bit better for within the flows, maybe, as opposed to the broader CMS message signing mechanism. So what we're really addressing here is just the use cases of where you have EAP and network access control, which is the wireless and other spaces.
802.11,
yeah, exactly.
Precisely so. And so to come back to sort of the questions, right? I think Alan answered in a relatively assertive way, yeah, eat it and do TEEP. And that's where my head is, because if we don't do that, we're going to recreate something that looks an awful lot like TEEP is my concern, though perhaps with a little bit of, if we recreate a method, it could be a little bit of Jose Cose glue, magic pixie dust instead of what's there today. And maybe that's the right thing to do, because we might be able to leverage what the ACE people are doing with their flows, at which point we do have to toss away TEEP, but that's a whole lot more work than I want to do. And I want to make it clear that I am a fundamentally lazy person, so I prefer to use other people's code and not have to wait for it. So I'm lazy and demanding in that regard. Then the next question that Nancy addressed, right, is sort of two sets of questions. First of all, we have this this one message that's available to us in EAP-TEEP to do enrollment. The question is, do we want to break out and start and take a better look at EST to see if there are other messages that are necessary, or should we break out of should we do some sort of EAP success and then break into and have devices end up in a sandbox environment, which sounds a lot more complex? There are all sorts of different possibilities that we could traverse here, but one of the reasons we like EAP in terms of doing all this is the client stack component that deals with this is relatively compartmentalized, and you don't bop an interface up at an L3 level and then bop it down and then bop it up again based on your provisioning state, which might confuse upper layer applications, which is something that we're a little bit concerned about. So again, it demonstrates the full value of EAP. And then, of course, the other thing we're thinking is, once you're up and running, you might not want to wait for an EAP transaction to do your re-enrollment. And the registrar is supposed to be available for this purpose, but you might not know the IP address of the registrar, because this would abstract that out from you. Whereas it's available, it's discovered in the Anima use case in other ways. So that's some thinking that needs to be done in terms of that. And there are other aspects here too, which is that we have constantly thought about ways in the Anima working group to where you might want to piggyback additional information back to what we call here the peer, such as a good example in the constrained space is that people are looking for a co-op resource directory. How could we pass back, one or two bits of information that might be useful to the client in this context? And this relates also, just because, I think broadly, though not necessarily deeply on these things. We're also looking at the work being done in the DHC working group, which is looking to do Yang models for all of the DHCP options, and some of those we might want to pass back as well in this process. There's limitations to that because some of that information is very, very localized to a particular network that a AAA server might not even have access to. So we have to be particular about that. But these are some of the things that we're pondering. And so that leads to the next question. As we're going through all this, a particularly mysterious thing to me is channel binding. And so I heard that. I'm going to repeat what Jim said. That's going to be a pain. When has it ever not been? Is my question. So anyway, I have just one question for the group left over, which is this something that you would be interested in working with me on?
I have one other comment before that question, you can ask the question, but it's not about that question, which is that you said there's the possibility of doing something where you do EAP and you get limited access and then you do some other protocol. And I know that sounds complicated. It also has the advantage of being nicely incrementally deployable, that you could go into a corporate network, some group wants to do this, they plop up their server, they run their devices, and they don't have to get the EAP infrastructure, all of the access points and access controllers and stuff updated. Sure. And if you don't do it that way, then you have the problem that you've either got to run other wireless access points in order to do incremental deployment, which most employers would not be pleased by, or you've got to somehow get your corporation to update the infrastructure before you can use this. And I wondered what you thought about that.
Yeah, so I won't speak for other vendors. Cisco has a notion, which I'm sure others do, called MAC Authenticated Bypass, which essentially allows for these sorts of incremental deployments. So you have devices that maybe don't understand EAP, maybe you have to learn them in other ways, learn about them in other ways. And that's just one example where, yeah, you might end up getting sandboxed initially, and then you do have to deal with these things. And Max is I'm sure going to talk.
That's not what I was.
Okay.
That wasn't actually my point. My point was that you're going to make these devices, and they do understand EAP, but you're going to expect these EAP extensions in order to get onto the network. And if I just walked into a Cisco office today, these things not being defined, those wireless access points don't have those EAP extensions. So I could do the beginnings of EAP, but then I couldn't actually get on the network.
That's right.
And
wouldn't those extensions go in the AAA? I mean, the AAA is where EAP terminates, not in the access point in most cases.
There's a question of whether you've got to get the corporate network to update their AAA infrastructure,
Sure.
or whether you could put a server up on the network, get in and just have them put that server on the same VLAN where they're giving you sandbox access if you come in as one of these devices. And I don't know which of those is better. It was just my comment.
It's a fair comment. And I'm not even gonna begin to say I have a good answer for it. Right? We're just getting going.
Just a comment.
Yeah.
Max Perdican, continuing that conversation, I wonder about if we put it onto a quarantine VLAN, how does the device know that it's in the wrong spot and know to try other SSIDs and roll forward? And maybe a more structure around whether or not the EAP method succeeds or fails because it got the right stuff or didn't have the right extensions might make that process fail over faster to find the right spot it's supposed to be at.
So just so that we're clear, right? My understanding of EAP is that one of the nice things about it is you have a way to send a soft fail in the protocol, and where the server can then try other things. And I suspect we'll see some of that at work here, but we might. I don't know how far we'll have to go in a specification on that front.
Yeah. So this is quite interesting and an interesting problem space. Certainly. Not sure about all the technical details, but
me neither.
But one comment that I would provide is that, at least in my experience, it's often useful to keep sort of the EAP to do the thing that it was originally designed to do, to authenticate in various different ways, and then use other mechanisms for delivering configuration information. And I mean, that's my experience, and that would be my advice. I realize that people don't always listen to my advice, and there certainly are people who've done not followed this particular advice. So and they're like, right now there's some people somewhere else who are doing something exactly against that advice. But that I would rather see a sort of a clean stack in some sense. I mean, enrollment is fine, but like this configuration of various other things, maybe not the right place.
So I think there's. Thank you, Ari. The key thing I just want to bring out there, that use case is really, it's hitting us hard in a couple of different deployments where you don't have DNS in some of these spaces. Yet you do have a little bit of EAPishness, as it were. And so the people are looking, and what they're using instead of DNS, or planning to use instead of DNS, is really the CoAP resource directory, and to locate various devices. And so they need one little hook. But of course, once you say one little hook, everybody has their own one little hook they want to find. And so this could grow into a monster, and that would be the thing that I would be concerned about. And when I mentioned DHCP, that's just the monster you were thinking about, I'm sure.
There are more nodes on the network that just want to find the DNS in an NTP server than want to find a CoAP directory, and we've never let them put those things in here. So I don't know.
Yeah. So there's tons of ways of discovering stuff. Multicast addressing, and I've done some work on CoAP resource directories, and that's not. I don't think that's a intractable problem. Also in other ways.
Okay.
And the other comment I would make is that we see this a lot. Like, we can't have DNS, we can't have this or that, but then we also do certificates and certificate chains, and it's a little funny because
what people think is important, in different use cases, right? But let me take as the conclusion from this discussion, when that comes up, is that these are not the droids you are looking for when we talk about EAP, okay?
Yeah, I think the other thing you might want is to have all that other stuff work on a network that isn't an EAP network. And that's, so that's the other thing you want to take
Totally
into account. And I'm interested in this, and I at least like to follow it regarding your question of work and would review stuff. I don't have resources to implement or anything.
Well, and so again, I think thank you, Joe and group, for so much time, by the way, for this. I really appreciate it. I think I like the idea of scoping it down just that much because it keeps us from boiling the ocean. And so I really do appreciate the advice. What I wanted to just close with is just to point out that my co-conspirator is sitting there in the back, Owen Friel, who's right behind Alan. And right in front of Alan is Brian Weiss, who gets suckered into implementing a bunch of this stuff too. And of course, Nancy. So we're all of us are trying to figure this out, working with different partners. And this will have to be an industry solution. It can't be a broad industry solution be going beyond the IETF. So there's a fair amount of uphill lifting here if we take this approach. Whatever approach we take, there will be uphill lifting for all of this. And we have to also work with I think probably the IEEE in this space to figure out the other problem, which is how do I choose what network to join in an 802.11 sense. I don't think they're quite done there, quite frankly. Yeah. And I'll just point out, let me also give one more bit of credit. I'd like to thank Dan Harkins, who also gave a lot of comment on this topic as well as he was going forward.
Dorothy Stanley, Hewlett Packard Enterprise. To your last comment, Elliot, about the work in .11 not being quite done from a discovery point of view, I would be, and I think the .11 working group would be delighted to hear your comments in that regard. And I would encourage you to put together a presentation and bring that to .11 to describe the use cases that you're looking at that are not completely addressed.
I'm going to sucker him to do that because he already goes to 802. but
yeah,
yeah,
perfect. Yeah. I don't know who him was, but
or we have some people to do that. But yes,
yeah.
I think it's a fair point. I can't just throw darts without actually.
So please,
I think it's fair.
Comment.
By the way, I do appreciate the work
Educate us.
that they have done, like AQ, as I mentioned, and the of course the Wi-Fi Alliance's work with DPP, which I think is directly relevant.
Which Dan has done a lot of work on. Yeah.
Thank you. Okay.
So yeah, I think there sounds like there's some interesting discussion that could happen. I think certainly paring down or compartmentalizing what you want to do, like perhaps working on enrollment or improving their enrollment in there would be a good thing. But I think we need to kind of figure out what's the right direction here for this sort of thing.
So having taken this input, it's now up to us to actually put out a draft. Because otherwise we'll continue to speak in generalities, and who likes that? So if you're interested in taking part of that effort, drop Owen or me an email, and we're particularly, additional advice on channel binding, always welcome, because as Jim said before he left, it's a pain, or it's going to be a pain. Okay, thanks very much for your time.
All right. Does anybody else have any other things they want to discuss with respect to EMU today? If not, you can have some time back. All right, we are adjourned. And if I could have the blue sheets. I have one blue sheet. Thank you. Yep. Yeah, but I'm just
Max Critic, Cisco, and
All right, back at EAP again. I was chair of EMU and we closed it when we started it in 2000 and whatever, and we closed it in 2013. There was EAP, and then there was EMU, and then there was now EMU again.